Okay, question 3. I did it in, when I sent you the answer, I did it in a long way. There's another way to do it using polar coordinates, which is also long. I mean, it's not really shorter than the one I did it, but they're both okay. So you have two different ways of doing it. So they want you to integrate this. They give you all the, oh, this is 3, sorry. They give you all of this, and they want you to integrate it. And when you start integrating, you'll notice that, well, it's kind of hard to just stick to z, so maybe you need to switch. From this one, x squared plus y squared, that's r squared. Then that means that the radius is positive negative 2. And also from this equation, we can get z equals 3 minus x. And you guys know from a polar system, x is r cosine of theta. To switch, there is one rule that you need to know. When they say dv, they mean dz, dy, dx. Or, in polar form, it's r dz, dr, d theta. So z, we'll put z. Instead of dv, going to put r dz, dr, d theta. Now, according to this, the first limits of the integral should be the z. And the limits for z, as you see, 0 and this. So this would be one limit, because it has to be in terms of the other two, and the other one 0. So 0 and 3 minus r cosine theta. The other limit is radius. And since the radius is 2, or minus 2, it goes of, like, say, 2 centimeters. So you go from 0 to 2. And theta, we usually go a complete circle. Now we integrate. I'm going to erase this part to show you how the integration is going to work. So we're first integrating in terms of z. So this becomes z squared over 2 with a constant r. We're going to plug 3 minus r cosine theta into z, and we're going to plug 0. And then what's left? You would integrate dr d theta 0 to and 0 to pi. Okay, first we plug in z, we plug this, so that will give you 3 minus r cosine theta squared over 2, or you can take half outside, 0 to 0 to pi. So you plug this times r minus, you plug 0, that gives you 0. And then you still need to do this dr d theta. So if we do this, we need to expand this first. So half outside, 0 to pi, and 0 2. This would be the first one squared. Then first times second times 2, 6r cosine theta. And the second one squared would be r squared cosine squared theta. This is expanding. You still times r, and still dr d theta. So half outside, 0 to pi, 0 2. Take the r inside, 9r r squared cosine theta, r cubed cosine squared theta, dr d theta. Now, since we are integrating with respect to r, so we have half outside, 0 to pi, 0 to, integrating this one would be 9r squared over 2. This one would be r cubed over 3, so it becomes 2r cubed cosine theta. And this one would be r to the power 4 over 4 cosine squared theta. And the two limits, so we did the integration, so we don't have to use these to show the 0 to. 0 and 2 and d theta. I'm going to erase this one here. So there's half outside, 0 to pi. We plug 2. 2 squared, 4. 4 over 2 is 2, times 9, 18. 2 cubed 8 and 2, 16 cosine theta. 2 to the power 4, 16 over 4. That's 4 cosine squared theta. Minus, if you plug 0 into r, everything will be 0. Now when you integrate with respect to theta, for the first one, 18, it's a constant, so it becomes 18 theta. And just put big brackets because the half is times the whole thing, and in between 0 to pi. Plus, integral of negative 16 cosine theta would be negative 16 sine theta. And you also put the two limits 0 and 2 pi. Plus, now the integral of this one is different. 4 cosine squared, when you integrate cosine squared, you have to use half angle identity. So, 4 outside as a constant, you're integrating 0 to pi. The half angle identity for this would be 1 plus cosine of 2 theta over 2 and d theta. So we put the half. Let's do the plugging as a last step. So the first one is 18 theta, 0 to pi. This one is negative 16 sine theta, 0 to pi. This is 2. The integration of 1 is theta. And the integration of this would be sine of 2 theta. And you're between 0 and 2 pi. We start plugging. If we plug 2 pi, 2 times this would be 36 pi, and plug the 0 would be 0. That's the first one. Sine of 2 pi is 0. Sine of 0 is 0. So the second one doesn't affect the answer. Here, we plug 2 pi, so you have 2 pi, sine of 4 pi, which is 0. Minus 0 and 0. So we have half here, 36 pi, 4 pi, that's 40 pi, times half, 20 pi. So this is the answer for question 3a. It's a long question, but this is how to integrate it and switch to the polar system. Now, the question in worksheet B was little bit better in terms of the equation was easier, or the question was a little bit easier. Question 3b. It was to integrate 0, 1, 0, 1 minus x squared, 0 x squared y squared, and it was x squared y squared dz dy dx. And I told you, dz dy dx is dv, and if you decide to switch to polar, dv becomes r dz dr d theta. Okay, let's see. First of all, we know x squared plus y squared means r squared. So this you can replace and say it's r squared. This is 0, and this also r squared. Now, you need to know your radius. Your radius would be, if you look at this portion, would be the square root of whatever this number is. So it would be the square root of 1. That's 1, so you're from 0 to 1, and complete circle. So this is the answer for this one. Now, if you integrate, it's r cubed. First integrate in terms of r cubed, in terms of z, would be r cubed z. And you plug r squared and 0. And you still have the dr, the d theta. And from 0, 1, 0, 2 pi. You plug r squared becomes r5 minus 0 cancels out, so you have r5 dr d theta 0, 1, 0, 2 pi. If you integrate with respect to r, that would be r6 over 6, and you have the 1 and the 0, and you're still integrating from 0 to 2 pi d theta. Plug the 1, it gives you 1/6, minus plug the 0, 0. So now I know I'm integrating 1/6 d theta 0, 2 pi. Integrating this would be 1/6 of theta, 2 pi is 0. You put the 2 pi, you put the 0, that becomes pi over 3 minus 0, pi over 3. So the answer for this is pi over 3. I'm also going to do another example of how to switch to polar system, which is question 4a. They tell you integrate from minus 2 to 2, from minus 4 minus x squared, 4 minus x squared, x squared plus y squared, 2, and x squared, y squared, dz dy dx. Okay, we know r squared is x squared plus y squared. That's we know. So, if we need to make this switch, this becomes r squared. And dz dy dx, that's dv, that's r, dz, dr, d theta. So, first we need the limits for z. It's the square root of r squared, which is r. And the top is just a constant. We need a radius. And I told you, for a radius, radius would be the square root of the number. So u radius goes from 0 to 2, and usually complete circle. So you're integrating r cubed dz, so that's r cubed z, and you put 2 and r, and you still need to integrate from 0 to 0 to pi, dr d theta. You plug the 2 r cubed, you plug the r, it will be r to the power 4, dr d theta, and you still have 0 to, and you still have 0 to pi. Integral of this would be r4 over 4 becomes over 2, cancels with this, r5 over 5, you put the 2, you put the 0, and then 0 to pi d theta. You put the 2 to the power 4, 16, and 32 over 5 minus the 0, d theta, 0 to pi. This is 8. 8 minus 35, 32 over 5 becomes 8 over 5. So basically you're integrating the fraction 8 over 5. And the integral would be 8 over 5 theta, plug the 2 pi, plug the 0, 2 pi, and 0. That gives you 16 pi over 5. So that's the answer for this. Now, only one concept left, which is the last question, question 5 in both of them. I'll show you this in my last part.